Good morning to one and all present here. So my name is Darshan Uttamistry and I'm going to present on the topic of CLIPDraw exploring text to drawing synthesis through language image encoders. So what I'm going to do present today is first the introduction, the objective, related work, methodology, results, limitation and future direction, as well as the conclusion. Yeah, so after seeing all these images present in there, so you might have known something similar to this, which would be Dolly 2. So yeah, the CLIPDraw is an algorithm that synthesizes novel drawings based on natural language input using a pre-trained clip model. Is a matrix for like maximizing similarity between the given description and the generated drawings. It optimizes like vector strokes towards simple human recognizable shapes. So and for the main objective of the paper was to explore the problems of generated drawings from text description. So a system called CLIPDraw, which like utilizes a combination of language and image encoders to generate realistic images given textual description, was the main focus of the paper. So for the related works, for the work related to this paper, there are four things like text to image synthesis to optimization, vector graphics, and also the follow-up work to the CLIPDraw. The first, the text to image synthesis. So like this work draws from the synthesis, which aims to generate images that correctly match a given textual description. GAN-based methods have enabled progress towards photorealistic image synthesis. Also, we have the synthesis through optimization. So, activation maximization is an alternative method to image synthesis, where a random image is optimized to increase certain neural activation of a pre-trained network. The CLIPDraw like builds of a set of methods to minimize the distance between the produced images and the given description phase. This constraint results in stroke-based images which must like capture large features such as shapes and outlines. The third one with the vector graphics. So like differentiable renders can be used to bypass the vector-based dataset limitation and generate drawings using like RGBA Bezier curves instead of pixel. Also, there was a work related to CLIPDraw. You can say a draft was this for to previously released to public research community, and a number of following follow-up papers have been published since then. So like there's one called the style CLIPDraw, which involves explicit image-based loss to CLIPDraw framework, whereas the other was the CLIPGlob, which extends CLIPDraw to use image patches rather than strokes and and the third one will be the CLIPARSO, which uses a clip to extract sketches from photos. Yeah, so I would say this four will be the related work for this. Whereas if we move on to the methodology of this, so the current objective of the CLIPDraw is to synthesize a drawing that matches a given description prompt using a like pre-trained clip model as a judge. The drawings will be represented by a set of differentiable RGBA Bezier curves, like each parameterized by 3 to 5 control points, thickness, and RGBA color vector. So now how does the algorithm work? So how does the CLIPDraw algorithm work? So we'll now discuss that. So the first will be the input. We'll be taking a textual description phase, the number of iterations, the number of curves, the augment size, as well as the pre-trained clip model as an input. Then we move on to the encode description phase, where the input description phase is encoded using a pre-trained clip model to obtain an encoded phrase. Next, we take the initializing the curves. We set of n curves as like randomizedly initiated. Then we move on to the fourth step. This is the render curves to pixels. The curves are rendered to pixels using a differential renderer to obtain the initial image. We then move on to the next step, such as to augment the image. The image is augmented using a data augmentation method to obtain a augmented images. Next, we move on to the to encode the images. So like each augmented image is encoded using a pre-trained clip model to obtain an encoded image. Next, we compute the losses, the cosine similarity between the encoded description phase and the encoded image is computed to obtain the loss. Now next, like we implement the backpropagation The loss is used to back propagate to the curves to optimize them. The curves are updated to minimize the curves. So at the end, so we'll repeat these steps for like I iteration to refine the curves and generate the final images. So after working on the algorithm, so we are getting this result. So like if you can see in a matrix, so like we tend to so we have like 5 things: CLIPDraw, pixel optimization, big can optimization, VQ GAN optimization, as well as CLIPDraw without image augmentation. So if we choose 7 use cases of that, so you can see in a matrix type shapes. So we can see that the CLIPDraw tends to result in a diverse set of human recognizable doodles, whereas the pixel optimization like creating interesting textures but fails to compose colors and shape, whereas the big GAN and VQ GAN optimization synthesizes high resolution image but are constrained to the set of images the generator can produce, whereas the images from the CLIPDraw without image augmentation score high numerically but are nonsense to the human eye. So what we can learn from this are the limitations and like how to go further into the future with them. Okay, this authors acknowledge like several limitations of the CLIPDraw system, including its inability to generate highly detailed or photorealistic images. It relies on the quality of the input texture descriptions and its susceptibility to producing biased or stereotypical images based on the training data. For the future result, they are suggesting several avenues such as exploring new methods for generating high resolution images and addressing issues of bias and fairness in image synthesis systems. Whereas after concluding, what we can conclude is the paper will be describing a system called CLIPDraw, which will be exploring the problem of generating drawings from text descriptions. The system utilizes a combination of language and image encoders, specifically the contrastive language image pre-training, which is called as CLIP model, and the DC GANs model to generate plausible images from given a textual description. Whereas the paper also presents experimental results showing the effectiveness of the CLIPDraw system in generating realistic image, as well as a user study demonstrating the usefulness of the generated images for creative tasks such as brainstorming and prototyping. So with this I would like to conclude my presentation. The following will be the references for my presentation, and if you have any question, feel free to ask. Okay, thank you.